All software development at this point is live. There's no, you waterfall, you build it out, you get it locked down, and then you figure out how to secure it. No, you are constantly, continuously integrating software. In order to get this to work, let alone work securely, we just had to build a much more agile, much more flexible, much more developer operations integrated pipeline, simply to survive. Enterprises are in a slightly interesting position where out there on the cloud, you have a lot of data that is in a public external space. In the enterprise world, the software is very private, it's very customized, and usually you're not moving the data to the outside. So enterprise has particular requirements for its DevOps. Still needs to be agile, but it's got to deal with the fact that the software is built in-house for in-house needs and the data is leaving the corporate boundary. It's a harder version of DevOps, but it's still DevOps.
What about the tools that companies have traditionally been using to secure this agile, or to secure the traditional network environment, and how is that faring in now a more agile environment? Do you feel that it's up to snuff, or what do they need to do to change to be in this sort of always live coding environment?
You know, it's all live, it's all moving. There's no stability, there's no slowdowns. When you're actually installing physical hardware, there's a rate at which you can change, and it's pretty slow. Like, one of my friends bought some servers, and it took 4 months to install it. He also went ahead and got some servers on Amazon, and it took 4 minutes. That kind of month-to-minute change is a fundamental shift, arguably greater than the shift from hard drives to SSD. Like, it's just a different world now. So even security hardware, you know, a lot of security hardware is actually tin. You're pushing tin, you're putting boxes in racks. And we just live in a different world now and have had for a long time.
So what does this mean to the security team, to the security professional, to the CISO, that things are moving from 4 months to 4 minutes? I mean, is it possible to have an architecture in place that just can physically withstand this kind of behavior?
You know, we do a lot of engineering in the automotive world to make sure that our cars are safe. And we do a tremendous amount of setting things up for when there's a crash, the driver lives. But at the end of the day, there's the driver, and he's got to not be like driving into walls. Like, some of the security models in advance, some of the security model is live and dealing with driving defensively. And that's how you have to see the world. You are setting things up to survive the bad guys. Everyone talks about attackers' advantages, but we have defenders' advantages too. We get there first. There's a game, we make the rules, and we don't have to play fair. We get to cheat.
Oh wait, so hold it. Then tell me, how do you cheat, and what's the environment you set up to, I guess, have a level up on the attackers?
One of our primary advantages we have on the defensive side is we don't need to discover the world in real time. We can actually be there first. We can do global discovery as we deploy. As we build out, we can understand our networks. Our attackers, the people who are attacking us, have to kind of figure things out as they go along. They have to get it wrong before they get it right. And so what I always advise people is be aware of the attacker discovery process. Don't think it's an instantaneous thing between there's a vulnerability, there's an attacker, there's an exploit, there's your data being exfiltrated. Like, there are stages, this takes time. Look for those data points and you will have an advantage.